Welcome to the National Air and Space Museum and our beautiful Moving Beyond Earth gallery. Today on What's New in Aerospace, we're going to talk about practicing underwater for walking in space. This is a really important technique, and we wouldn't know how to do extravehicular activity, or EVA, without having mastered this technique of working underwater. I would also like to welcome all of our viewers on NASA TV and online. Later in the program, we will have a Q&A session, and if you go to our website, you can send questions to be asked in the Q&A session, and if we're lucky, we'll also be able to send questions to the engineers working in the pool, because today we're going to connect live to the Neutral Buoyancy Laboratory in Houston, outside the Johnson Space Center, and actually talk to them when they're working underwater. But first, I want to show you a short video which kind of gives a preview of what I want to talk about on the history of neutral buoyancy, or working underwater for EVA. So why don't we roll the video? The 50th anniversary, or yesterday was the 50th anniversary of Alexei Leonov as the first man to walk in space. And he went outside of his spacecraft for like 12 minutes in 1965. A few months later, on June the 3rd, 1965, Ed White became the first American to walk in space. And this is a picture, a movie of him leaving the spacecraft Gemini 4, and Gemini 4 is right down the hall in this museum. And a lot of the equipment you see him wearing is now in a gallery called, or exhibit called, Outside the Spacecraft, that's just upstairs in the museum. This video is actually of some of the things I'm going to talk about today. It's from a little company called ERA outside Baltimore, working in the mid-1960s. They are one of the pioneers in the development of the technique of working underwater for practicing EVA. And this video shows some of that early work with an airlock. And the pictures that follow show more of this work that I'm going to talk about a little bit more in my introductory PowerPoint. Here's somebody coming out of an airlock. They're wearing a so-called Mark IV Arrowhead suit, and these are some of the tests that took place outside Baltimore in the mid-60s. They moved on to using a Gemini suit. This is one of the founders, who I'll talk about more in a minute, of ERA. Scott Carpenter working underwater with a test section for Skylab, and you can see the Skylab module just outside here. And these pictures are from Gemini 12 and Gemini 9 simulations that took place. This is Gene Cernan, the astronaut, and then Gene Cernan working underwater. And here's Buzz Aldrin in Baltimore in about November 1966, and shows him getting into the water and working underwater. This is really the first time, and I'll come back to this, the first time that walking in space was really trained, and astronauts were trained to do it. And then you see here some of the Apollo era. So once Houston had its own tank in 1967, it began working on the underwater training. And for the later Apollo missions, they had to go outside and retrieve film from the service module. This shows a tank and then the construction of a new facility, which I'll again mention in my talk. And this is the second Houston facility. And then we have here some of the training that took place in the shuttle era underwater for working in the shuttle payload bay. And then for going outside, this is, of course, Bruce McCandless in space with MMU. And finally, at the end of this video, you see a little bit of the training for the Hubble repair missions. And this is a video from the training for the last Hubble repair mission. And if you go right outside this gallery, you can see the instruments removed from the Hubble, and you can see much more about this. And also within this gallery, there's information and artifacts related to the working in space by the astronauts on the Hubble repair. So what I want to talk about today is how do we get here, and the beginning of our understanding that working underwater was absolutely crucial to learning how to do EVA. This was not as straightforward as it seemed to be. So if I could have my first slide, please, and go to the next one. So early on in the program, there was wasn't a very good idea about how to train for EVA, how to go into space. And there's a picture on the upper left, a NASA picture, which was a conception that somehow a guy in a spacesuit was turning a wrench, and you can see he has absolutely nothing to support him or hold him into place. In many ways, some of the effects of working in weightlessness were just not anticipated. What NASA had for training for EVA or for weightlessness was the aircraft. You can, in an aircraft, actually experience free fall for 10 to 30 seconds. So that's not a simulation, that is actually weightlessness, but the aircraft goes up and down and you only have at most maybe around 30 seconds of actual weightless experience. It's pretty hard to simulate or experience what it's like to work in weightlessness if you only have 30 seconds. And another tool they had was a so-called air-bearing table, where there was an extremely smooth surface and a thing that created an airflow that floated you above the surface, and you could practice on a friction-free surface. But it only allowed you to move around in 2 dimensions. It didn't allow you to really experience what it's like to work in zero gravity. Next, please. And there was some interest in using water to understand the effects on the human body. So there were physiological experiments made, like this one at Brooks Air Force Base in San Antonio in the early 60s. What were the effects of zero gravity on the human body? And so subjects were immersed in water for some time, but no one really thought about, could we train astronauts that way? And certainly after the program moved to Houston, they just really weren't interested in this technique yet. And next slide, please. So the actual history of learning how to use the water came out of Langley, NASA Langley, which is down in Hampton, Virginia, down near Norfolk. And it started with a space station project called Manned Orbiting Research Laboratory, and this model shows a concept for a small space station that a Gemini capsule, which is attached to the top, would go to. So could we start a small station in space? Meanwhile, of course, the president had committed to go to the moon, and that was our overwhelming and important mission in the 1960s in human spaceflight. Next, please. Now, one of the problems of this station was, how do you get in and out of it? And one of the founders of this little company I'm going to talk about now, Sam Mattingly, actually suggested to them that they needed an airlock on the station. You needed a way to get in and out of the station without letting the pressure out of the whole station. And so this picture shows a couple of spacesuited test subjects working inside a plastic airlock, which Langley built to try to understand how you would go through such a thing and open the hatch and close the hatch. But the problem was, of course, this is a 1G simulation. This is on Earth. They're not floating. They do not have the reality of zero gravity. And so the suggestion was we should take this airlock and immerse it in a pool. And that suggestion actually came out of this little company, ERA. Next slide, please. These are the founders of ERA, Environmental Research Associates. It was a tiny company outside Baltimore, headquartered in Randallstown. And the founders were Harry Lotz, who was the scientist, the one with more scientific training, and G. Samuel Mattingly, who was the business and engineering genius behind this company. And I wanted to recognize today, because we have in the audience actually the sons and grandson, with son Randy and Dave, grandson Brett, and also 2 of the divers and guys who worked in the pool at ERA, Bruce Tharp and John Mick. So if you could welcome them. So this tiny company began to work with Langley on how you would immerse this airlock in a pool. So if we go to the next slide, please. They actually went to a school outside Baltimore, the McDonough School, which is still there in Owings Mills, And Sam Mattingly knew that their pool was a pretty good quality pool, and they didn't have a pool of their own, so they suggested to Langley that they take their experiments into this, and they made a deal with McDonough School to work in this pool literally outside normal hours or when the swim team. So you got to realize this is a school pool. You have the swim team, you have the swim hours and whatever, and you're going to fit some experimentation in at night or on the weekends or in the morning, early mornings and things like that. This is a picture actually taken of the McDonough School pool in the mid-60s. Could we just go to the next slide, please? And this shows some of the experiments that took place at the McDonough pool. Some of these slides you saw before. In the initial presentation, shows the testing of going through the airlock, how you'd open the hatches, close the hatches, turn around inside with water. One of the really important things that Harry Lotes, Sam Mattingly, and his divers, including John and Bruce here, had to learn was just how to work in this environment and make it a realistic simulation. So if you're in a spacesuit, you're going to float. I mean, you're in a bag of air, essentially. So if you have no weight on you, you're just going to pop to the surface. And so one of the many things they had to learn was the proper weighting of lead weights around the suit to create a neutral balance, so-called neutral buoyancy, in all axes, not just going up and down, but in every dimension that you move around, and makes a pretty reasonable simulation of what zero-G is like. Next slide. And you see in this next slide another one of these tests getting in and out of the airlock. They also had to learn a safety culture. I think that's one of the really important things I learned in studying about this. They had to learn a safety culture about how to work in this. You had to have divers, you had to have scuba divers always with you in case there was a problem with the suit. And at times people, including Bruce Tharp here, experienced personally an emergency created by losing the air connection to the suit, water potentially coming into your suit or your face mask. And so they had to learn how to work with this. Next slide, please. Now, simultaneously, Marshall Space Flight Center in Huntsville, Alabama, was working on neutral buoyancy. They started working in 1965, and this is a picture. This is a picture of an outdoor tank that was at Marshall, and also then later they developed the outdoor tank, they covered it, they heated it. And so neutral buoyancy training began in two places in NASA. One was through Langley and the ERA project, and the second one was through Marshall. Next slide, please. Now, in between, as I mentioned in the introductory video, the first humans went into outside the spacecraft. Alexei Leonov, and next please, Ed White. These walks in space, could I have the next slide, please? These walks in space demonstrated that we could go outside, but they were also kind of misleading. We didn't realize how hard it was because they were just floating around for the most part. And secondly, the Soviets covered up the difficulties that Leonov had getting back in his airlock in his spacecraft. And even Ed White had a lot of problem getting down in his suit and closing the hatch. But in general, the message we got from the first two walks in space that happened in 1965, that isn't so hard. Next slide, please. This is a picture that you saw before of Gene Cernan. So when we really found out how hard it was to walk in space without proper preparation and training was when Gene Cernan went outside almost exactly 1 year after Ed White. On June the 5th, 1966, he went outside. He was to go on the back of the Gemini 9 spacecraft, put on this fancy backpack that the Air Force had built, and he was supposed to jet around with this jetpack on his back. But that turned out to be a disaster because just getting into this, strapping himself in, hooking up the hoses, hooking everything up, and getting ready to go proved to be so incredibly exhausting that he was completely fatigued. His sweat ran down from his forehead, ran into his eyes, fogged up his faceplate. He couldn't see. He was almost completely exhausted. And his commander, Tom Stafford, told him to get back in the spacecraft. And so he had to come back to the spacecraft. It was a near fatal accident. And it demonstrated how little prepared we were to actually do effective work in space, how little we actually knew about it. Could I have the next slide, please? Now, coincidentally, ERA, 10 days after the Cernan walk, gave a demonstration to a bunch of officials at NASA. This was done in large part because at that point, ERA's contract was about to run out and the whole business might go away. And ERA staged a demonstration for NASA officials. Well, it happened to come at exactly the right time because now somebody from Houston was sympathetic to the idea that maybe we could learn something from working underwater for walking in space. And so on the upper left, there's a picture of a Gemini 10 simulation. Gemini 10 was going to be launched next in July. And then Gene Cernan came back. Next slide, please. This is a Gemini 9 simulation that he took place in the summer of '66. Next slide, please. The really important moment for Houston was when Bob Gilruth, who was a great pioneer and head of the Houston Center, decided on July 25th, '66, we want to have our own tank and we want to learn from what ERA has done. And so from that point on, Houston then committed to working on neutral buoyancy. Next slide, please. And one of these things was working on a so-called Skylab type simulation with Scott Carpenter. Next, working on Gemini 11 on a simulation, and then next, Buzz Aldrin. Buzz Aldrin being prepped for the pool. Next, going into the pool, and next, and working underwater. The training of Buzz Aldrin was really a crucial thing. That was the point at which the ERA experience was passed on to Houston, and they understood how important it was. Next. You can see here the Gemini mock-up entirely in the pool, and Buzz Aldrin working underwater in the McDonough pool. And next, you see this is a picture that Buzz Aldrin took, and he recently tweeted out as, quote, the greatest selfie ever, with typical modesty. And it's signed to Sam Mattingly. It is personally dedicated to him because the Gemini 12 walk in space in November 1966 was such a great success. Next. And so you see here the tank that Houston actually rebuilt. It was used for water training, for getting out of the spacecraft. The astronauts were trained in scuba. And next, they began working under the water in the Apollo program. Next slide, please. Can we have the next slide, please? And working underwater in the Apollo program in the Houston tank. And next. And Marshall also built a huge tank, 75 feet across, and that was a really important tank for the development of Skylab. Next. This is the second facility which we saw in the opening video with the called WET-F. This is used for the shuttle training. And then finally, in 1992, NASA built the huge neutral buoyancy laboratory outside Houston. And we have a little introductory video which just tells you something about the NBL.
At a length of 202 feet, a width of 102 feet, and a depth of 40 feet. The Neutral Buoyancy Laboratory is one of the largest indoor bodies of water in the world. As a world-class facility near NASA's Johnson Space Center, the NBL plays a key role in meeting time-critical challenges for astronaut training and refining procedures for successful spacewalks. Continuing in the spirit of advancing technology and science, the pool's 6.2 million gallons of chlorinated fresh water is maintained at a comfortable 84 to 86 degrees Fahrenheit. With a system capable of turning over the entire pool in 19 hours, the water is filtered and cleaned keeping a hygienic environment for any operation. Logistical planning for moving large-scale models for testing has never been easier. Conveniently located next to Ellington Airport with access to a taxiway, hardware can be brought directly to the facility. From there, the NBL's 2 overhead cranes, each rated at 20 tons, 4 jib cranes, each rated at 1.6 tons, or 2 davit cranes can carry your workload directly to the pool or to the pool side.
So, here we are, and I think we should now have a connection to Houston. Houston, can you hear me?
Even though it's a temp stow, we want the first 2 to have 3 twists so that we've got the cable securely down.
Okay. We're seeing now the simulations that's taking place on airlock work underwater at the NBL.
Copy. Copy. So Farouk, for you, you'll be looking along the cable, the free length of the cable for that center wire tie, and that'll go on 286, the forward stanchion. And we may need the divers to help move the aft part of the coil out of the bag and a little closer to you to make that reach. Sandy, you're going back to the bag and getting the aft coil out.
Okay.
So I believe what they're doing here is trying to understand how to repair a particular airlock on the space station.
Some Velcro loops holding in the bag, you can release those. I'm sorry, Sandy, I missed what you just said.
I just wonder if you weld them up a little tighter this last time or not. Know how much excess we had?
I do not. So for both Sandy and Farouk, you are now live to the NBL. They are, the Smithsonian. They are observing you and listening in, and probably in a few minutes we'll begin the interview. So we'll keep working until then.
Copy.
Copy all.
So that, first I think...
286, you said you want 3 twists.
3 twists on the forward stanchion of that handrail.
Okay.
Now, of course, in the pool, there's no forward stanchion.
You just
So
get close.
shortly you're going to be
Or
able
you
to
get
ask
the
some
other
questions.
point.
Okay.
And Sandy, I'm here in 1 minute until you start your Q&A, so we'll have you hold off on pulling the cable out of the bag.
Okay. Let me put my local down.
Yep, put your local down, and for the float camera, if we can just get a nice view of Sandy's face and torso, and Farouk will let you finish wire tying your cable.
All right, the divers might have to hold me stationary in front of the couch.
Hi, gentlemen, can you hear me? Or NBL, can you hear me?
I think I can. We can hear you loud and clear.
Hi, it's not only a gentleman, I apologize. Yeah, could you tell me your names and who you are and what you're doing today?
There, I'm EV1. My name is Sandy Moore, and I am working on laying out the IDA2 cables, which will provide power and data to the second international docking adapter, which will come up later at the end of this year.
Mm-hmm. So are you pioneering the technique that the astronauts will have to use?
That's correct. So I'm in charge of the choreography for this EVA, and I actually am practicing it today and seeing how it'll work for my upcoming crew development runs.
So tell me...
Hello, my name...
Yes, go ahead.
Yes, my name is Farouk Sabor. I am the EV2 position in the water today, and I am helping with Sandy with working out the choreography and the plan on the EV2 side of the cable. So there are a number of cables that we have to lay out right now.
So this docking adapter is being refitted for new spacecraft?
I'm sorry, I didn't hear you.
The docking adapter that you're working on is going to be refitted for new spacecraft to dock to the space station?
Yes, it is. So these cables are more for the second docking adapter. On a previous EVA, US EVA 29 and 30, they were setting out the cables for the first docking adapter.
So could you two tell the audience who here online and in the audience here in the museum who you are? You're engineers working at Johnson Space Center?
That's correct. We're engineers, astronaut instructors, and flight controllers. So we help teach EVAs. We help certify crew members for spacewalks, and then we help execute and mission control while they are on orbit, and help real-time problem solve when they run into issues.
Must have had a lot of training because clearly you have learned how to use the spacesuit, work in the spacesuit just like an astronaut. So maybe you could tell us something about what it takes to actually do what you're doing now.
Yeah, that's one of the questions I get the most is how can you train astronauts if you're not an astronaut? So most of the training that we get is right here at Johnson Space Center, where we train, we do many of the same things that the astronauts do, including getting in the suit and running these choreography runs in the water. We also talk to a lot of other astronauts about their experiences in space and how they differ from being in the water. And then so a lot of these training that we get right here at Johnson Space Center, and then we use the engineering training that we get from schooling to help us be able to plan and develop choreographies that will work best for the astronauts in space.
All right, thank you. Now we'd like to go to the audience, and if anybody in the audience here would like to ask a question directly to the engineers in the pool in Houston, we're happy if you could just go up and go to the mic here and come around and go to the microphone, and maybe you can talk directly to Houston. So if you two will have a little patience here, we have a young man here. We have actually a number of school classes here, and he'd like to ask you a question.
My name is Malachi, and I'm from Friendship Public Charter School. And my question is where do y'all go to like fix the little quiet little things, like how y'all fix the little cables?
I think he's asking, how do you fix the specific cable that you're working on?
How do we attach them?
Yeah, describe a little bit how that works and how you're doing it.
These are the longest, and they're not in the pool, but on the orbit are the thickest cables we've ever installed. So we actually start at a center point, and we attach a wire tie, and then we route part of the cable aft in station, and then we'll route the rest forward. We kind of started in the middle, so it makes it a little easier than handling the whole cable all at once. We attach them using something called a Russian wire tie. And it's just a piece of copper, and it allows us to twist it and bend it much like a twist tie.
Thank you. Now I'm told that we have a viewer question on first from online or from TV. Does it feel like you were in space when you were underwater, or is it much different? Is a question sent by Betty.
Yeah, so there are similarities and there are differences. So in the water, the suit is the only thing that is neutral buoyant. So your body, your blood pumping, and all of that stuff still has gravity. And the tools, as you can see, they still fall with gravity as well. So the gravity of the tools, and when you turn upside down and you feel the blood rushing to your head, that is very different. But the sensation of being able to orient your body, that is very similar. Oftentimes we hear from the astronauts how similar training in the pool is. Now, one of the biggest differences is the drag of water. So in space, it is real easy to get started moving and really hard to stop because you have a lot of momentum from the mass of the suit. And in the water, it's really hard to get started as you're displacing the same amount of water as the mass of the suit, and it's real easy to stop.
Okay, next we have a question from another young man. I would like to.
My name is Xavier.
Oh, he forgot his question. Now we have a young lady. What would you like to ask?
My name is Michaela, and I'm from Friendship Public School, and my question is, how long do you train before you actually go up into space?
How long do you train before you actually go up into space?
Repeat the question, please.
Actually go into space, or for the astronauts, how long would they have to work before they go into space or execute a particular EVA?
So they come as ASCANs, and they do several runs to be certified as an astronaut. Once they're certified, they can be assigned, and they do 10 pool runs. And at that point, they have a skill set that they take with them, and they can do any EVA. EVAs in particular are designed and trained about 4 times in the water, and then we send it up to the crew, and they execute it on orbit. They may only do the actual EVA in the pool once, maybe twice, if they're lucky. We train astronauts quite a bit differently than we used to with shuttle days.
Okay, thank you. Now the next is an online question that we've been sent. And do astronauts wear the same EMU suit in the NBL as they do in space?
And then so for the most part, there are an awful lot of similarities. So one of the things that doesn't work so well in the water is electronics. So they took all of the electronics out of the EMU that we currently have on as opposed to the one in space. So with that, the entire backpack for in the water is just a volumetric simulation. So we get our water and oxygen from an umbilical cable as opposed to the backpack that would have all the electronics as the EMU in space.
Okay, thank you. And next we have an audience question.
How do the space astronauts breathe underwater?
How do you breathe in the spacesuits underwater?
So there are pressurized suits, and there is oxygen that is fed into our pressurized suits. So basically we're a big balloon right now, and we breathe that oxygen, and then we release our CO2, and they keep flushing new oxygen in, and that's how we breathe in the suit.
Question from a young man.
How do you move around with a heavy suit?
How do you move around with such a heavy suit?
So the question.
How do you move around in a pressurized suit?
Good question.
Yeah, so largely it's similar to how you would move around anywhere, except for the suit is a little stiff around you because it kind of expands like a little bit of balloon, but it is constrained by all of the rings inside of it. So you can move, it has wrist rings right here where you can move your entire wrist around. And then the shoulder joints are not like our shoulder joints outside of the suit. You have to roll them. And then so once you get used to this sort of action, you can use this to translate across the station or do any actions within this work envelope right here. And then you have to use your arms to react against different forces in order to move around.
Question from a young man.
How do you talk?
How are you able to talk underwater? That's the question.
One more time.
The question was how you were able to talk to us from underwater.
Good question. So we actually wear a comm cap, and within that communications cap, it has the ability for us to communicate using communication electronics up to the test conductor room and the test director room, and they can talk back to us via our voice loop within our comm cap. Sometimes it's referred to as a Snoopy cap. That's what looks like the one Snoopy wears on the commercials when he's flying the airplane. These are based off the Apollo days comm cap, and I think the design has not changed very much.
Yeah. So they have a little cap with a microphone and headphones inside of it, and a wire to the outside. So we have another question.
Friendship Public Charter Schools, and my question is, how much does the suit weigh?
How much does the suit weigh?
Yeah, so from my understanding, when the suit is on the dry, it's about 300 pounds. So it would be really difficult to walk in this suit. But when you're in space, 300 pounds has no weight. It just has the mass of 300 pounds. So it's really easy to move in space.
Okay, thank you. And I'm told that we have one more online question that we have. Can you drink water in the suit in space and underwater? Says Joe.
And actually, we have a drink bag with about 32 ounces of water, and this blue thing right here by my mouth is how we drink. It opens and closes by biting it. It's called a bite valve.
So do we have one more question from the audience, or?
Hi, my name is Matt Karen Napoleon. I'm from Public Charter School, and my question is, who built the suits for the word?
Who built the spacesuits?
Did you say who built the spacesuits?
Yes.
I think it was Hamilton Sundstrand, is that correct?
No.
And then so there are several different spacesuits right now that are in the process of being designed. But the one that we have now, it's been around for like almost around 30 years.
Okay, well, thank you very much. We're just, thank you for coming online with us and talking to us, and we don't want to hold you up any longer, but we're going to watch you for a little while longer while you work underwater. Thank you. Okay. You can sort of see that they're working outside because with the International Space Station, it's being continuously refitted, modified in order to get new spacecraft to go and dock to it. In order to keep it in operation, it requires continuous maintenance, and so we have the people in Houston down here. These guys, in case you didn't get it, are engineers, but they train the astronauts. So they first figure out how to do it, and then the astronaut crews come in, and they do the same thing, or at least try to understand it. One of the differences is that on the space shuttle, they would train very specifically, like for the Hubble Space Telescope, for very specific missions. And they'd train over and over and over again to do that mission until they had it perfect. But on the space station, the guys are up there for 6 months, or women are up there for 6 months at a time, and they have to be flexible. So they have to be able to go outside and do something. Sometimes they've actually gone outside and fixed things on the space station, so they weren't able to get the absolute choreographed, perfect spacewalk beforehand. They had to get general training from these people who are in the pool today and from others like them, and then they had to work a bit on the pool on various procedures, and so that in an emergency they could go outside to fix something and they'll be ready, or sometimes just for routine activities that they need to go outside. So the space station kind of needs constant upkeep and maintenance during its staying in orbit. And you know, even though we don't have a spacecraft that can launch astronauts to the space station, I should underline the fact that Americans are in space now, you know, on the space station. New crews are always being launched. Right now, we're only using a Russian spacecraft to get there, but by 2017, we're again supposed to have, this time, commercially operated spacecraft to take crews up to the space station, so that they will be keeping the space station going at least until the 2020s. And right behind me here is a model of the full International Space Station, which is a huge thing. It was the size of many football fields. And at some point here, we're going to open it up again for Q&A for me personally, since we had to let those guys go back, the lady and man, to go back to their jobs working in the pool. But whenever we're ready, we can have a Q&A session. So, yes, go ahead.
Okay, so when do they go to the bathroom at?
How do they go to the bathroom? Well, in the suit, or these days they wear diapers, basically, is the answer. Yeah, but in the space station they have real toilets. In the space station, they actually have zero-G toilets. I think one in the Russian part, one in the American part of the space station. But, you know, when you're inside a spacesuit for 8 hours, you obviously have to have some backup plan. And that's the kind of time we're talking about when you're inside that suit for a long periods of time. 6, 7, 8 hours. They have the drink bag so that they at least can not be thirsty, and they have to have some way to go to the bathroom. So, another question.
Hi, my name is Kendon from Friendship Public Charter School, and my question is, how do you fix the wires underwater?
Looks like you've got it wrapped with your left arm behind your back and up, and don't have.
Well, I mean, essentially what they're doing is figuring out how to tie these cables to the space station. So what do you need to do? How do you need to move them? How do you divide up the tasks to do that so that they have, you know, ties and things that enable them to pin it down to the spacecraft? Now that's what they're doing. They're learning how to do that. And then they can tell the astronauts how to do it, and the astronauts can do it in space.
Unfortunately,
Yeah. Yes, next question.
Hi, my name is Ortega, and I go to Friendship Public Charter School, and my question is, how do they make spaceships? What tools do they make? What tools do they use when they make spaceships?
What tools do they use when they build the space shuttle, work on the space station?
What tools? Well, they actually have a whole lot of special tools that they have to build for space. They're both lightweight, and you see some of them over here if you want to go after the show's over and look at some of the exhibits in here. That they have to have special tools. And sometimes they have like drills and things. They're zero reaction tool. That means when you try to take a bolt out or screw a bolt in, it doesn't create a force that turns you on your own axis. Because here's one of the realities. I mentioned this in passing in my talk. You know, in space, you don't have the ground and the gravity holding you there. So if you turn a screw, your body wants to go in the opposite direction. Isaac Newton, third law of motion. For reaction is equal opposite reaction. And one of the good things about this kind of neutral buoyancy or underwater training is that it gives you some sense of that. If you're not anchored properly, or if you don't have a special tool, you're going to turn. And so it's understanding that process and how you can work in space. It turns out you have to do everything slow and carefully rather than rushing. One more question? Oh, it was an online question, I've been told first. Do other countries have similar training facilities for their astronauts? It's an online viewer. Absolutely. In fact, in 1980, the Russians built their own so-called Hydrolab, which they use to train for their space stations and now train for the Russian cosmonauts to work on ISS. And then in more recent times, the Japanese built a tank, the Europeans built a tank, and now the Chinese built a tank. And so the Chinese actually have their own manned space program, and they have their own small stations they've been launching, and they've actually already had Chinese astronauts going outside. So yeah, it's become NASA really is the pioneer of this, but it's going around the world, or it has gone around the world.
Hi, my name is Quentin Morrow, and I go to Blow Pierce Friendship Charter School, and my question is, do they practice the same things over and over again or new things every day?
Do they practice the same things over and over again or new things every day? Well, sort of both, and it's a good question. I mean, to do a lot of things, they have to repeat and repeat and repeat in order to be comfortable that we have the technique down that we need to do something. And so anyway, thank you very much for coming. I want to thank the Boeing Company for sponsoring What's New in Aerospace and for sponsoring this show. I want to thank NASA and for the NBL for working along with us and talking to us today, so maybe we should give them another hand. And I wanted to thank the crew here in the Air and Space Museum for supporting our show today. Thank you very much for coming.